Hello Year 6. I've realised that you've been stuck with kind of the same wall and photo in my background for quite a while, so thought I'd mix it up a little bit and go here. It's almost like I'm like angelic with the light behind me. Anyway, arithmetic. So yesterday you should have done the 15-minute test. Now if you've not done that, I suggest you pause now and do it for 15 minutes because otherwise I'm about to go through the answers, and if you just sit there and watch me do the answers, then it's not that important. Some of you might be thinking, oh great, I've not really got to do any work today. And you've not really actually got to do much work in this little arithmetic session. However, learning from the test is more important than doing the test. So let's make sure we do it. So I'm going to go through the questions. I'm going to move us into our screen. It's more my screen, but you're welcome to share it with me. And then I will show you how I will have done the questions from yesterday. Okay, here we go.
Ruben's in the other room and he's like a wild dog, so you probably will hear him a bit, so I apologise. He might even appear, who knows. However, arithmetic. So today we are going to just go through the questions like I've just said, and I'm going to show you how I would solve them. So question 1, 92, add 10. I mean, we are just adding 10 to that. If you need to use your fingers, do it, but I imagine most of us will probably quite quickly be able to add 10, so to get 102. Or if we needed to, we might have added 8 to get to 100 and then another 2, but 92. 367, add 9. Now most of us probably just use mental methods, but I'd probably add 10 to get to 377 and then take away 1 to get to 376. Now I'm going to be honest, at some point during this, there's a good chance I'll make a mistake. If I do, just let me know about it, I'm sure you will. So 376 is our answer. Okay, first two really straightforward. Question 3, we're adding fractions. Now if the denominator is the same, so we've got 4/5, add 2/5. So if the denominator is the same, then we don't need to do anything other than add the numerators. Okay, common mistakes, somebody might well have done it, is they end up writing 6/10 because they do 4 add 2 is 6 and 5 add 5 is 10. That is definitely not right. If I was adding 4 pencils, add 2 pencils, it suddenly doesn't become 6 bananas, it would still be 6 pencils. Okay, so our answer is 6/5. Some of us might have tried to be fancy and change that to 1 1/5. My advice, don't bother. In an arithmetic test, don't bother. Okay. Question 4. For this, we are subtracting. Doesn't matter that the missing numbers here at the start, doesn't make any difference at all. So some of us might have taken away 700 to get to 3,862 and then another 8. Some of us might have gone for a written method, and if you did, I wouldn't blame you. 4,562, take away 708. The problem with this is there's a lot of exchanging involved. So I'm going to need to take one of those 10s and make it a 5 and add it on there. So then I get 12 to take away 8, which is going to be 4. Then I've got 5 10s take away no 10s, that's 5 10s. And I've got 500s take away 700s, can't do that, so I'm going to take 1,000 off there and put it on there to get 1,500s. 1,500s take away 700s is 800s, and then I've got 3,000s left, 3,854. Does that sound about right? It does to me. That is question 4 done. As always, you can obviously pause these, come back to it. 3 times 9. Most of us will just know that. If you need to count up in 9s, you can do 9, 18, 27, but the answer is 27. Next one, 4.5 at 0.72. We could use a column method for this, but I'm actually going to do it this way. So I'm going to add 0.7. Well, add 0.5 gets me to 5, add another 0.2 is going to get me to 5.2. And I've got to add on the 0.02. Which will get me to 5.22. Some of us might have used a formal column method for that, and if you did, that's okay. Next one, 50,000 take away 435. Now for this one, I definitely wouldn't have done this, okay? I definitely wouldn't have done this because then you've got all sorts of like taken aways and it's just horrible and nasty and definitely not worth doing. So don't do that. Instead, I would be using a number line for that. So if I was starting off with 50,000, I would take away 400, so I'm still going to be 49,000 something. So it's 49,600. Then I would take away the 30 to get to 49,000. Oh man, I'm making a mess of that. I'm going to have to rub this out. Sorry. I was quite enjoying my big cross, but I'm going to run out of space. 49,570. And then take away the 5, so 49,565. Now the other way of doing that is kind of adding to it. So I could have started off with, I could have counted on to start off with 435, add on 15 is going to get me to 450. Add on 50 is going to get me to 500. Add on 500 is going to get me to 1,000, which means that to get to 50,000, I've got to add on 49,000. So my answer is 49,565. It's a bit of an awkward one, that one. It is an awkward one, but that's the right answer. Like I said, some of us might have used a written method, but I wouldn't be doing for that because it just looks messy with all of the zeros. So next one, 2 4/5 times 3. Now hopefully if you can remember from school, if we've got a question like 2 4/5 times 3, one of the things that I really don't like is mixed numbers. So we're going to make them improper. So how many fifths are there in 2 wholes? Well, it's 2 times 5, which is 10, plus those 4. So I've got 14 fifths times by 3, and I'm going to make that a fraction by doing 3/1. And then if we're multiplying, we're doing 14 times 3. Well, I can do a bit of jotting. So 10 times 3 is 30. 4 times 3 is 12. So that has got to equal 42. And then 5 times 1 is 5. So my answer is 42/5. And I'm just going to leave it like that. Okay? There's no point trying to do something that is going to make a mess of it. Have I copied that down right? 1 minute. 2 times 14 fifths. 14 times 30. Yeah, I'm quite happy with that. You can tell me if I'm wrong. That's question 8. Question 9, 6 squared add 8. Now, we need to know what this little 2 means, and hopefully you know that it means squared. So that means that it's 6 times 6 add 8. 6 times 6 is 36. Add the 8 is going to equal 44. Okay, this means squared, which means that you times this one by itself. Next one, 6 times 60. For me, I would be using this, and I'd be doing 6 times 6 is 36. But it's not a 6 times 6, it's 6 times 60. So this is 10 times bigger. So I need to make this 10 times bigger. So my answer is 360. Question 11. 6,934 divided by 4. So I would say there's 2 different ways of doing this. One, if we're dividing by 4, we can half and half again. So if I've got 6,934, I can half and half again. So half of that's going to be 3,000. Half of 900 is going to be 450. Half of 30 is going to be 15. Oh, this gets a bit horrible. And half of that is going to be 2. Then half of that's going to be 1,500. Half of that is going to be 225. Half of that, and this is horrible, is going to be 7.5. And half of that is going to be 1. So when I add those up, I'm left with 1,500 plus the 200, 1,700. 1,725 plus the 7, 1,732. 33.5, 1,730, I can't remember what I said now. That and that is 1,725 plus 133.5, which to me seems wrong. but it might just be a rubbish question. The other way of doing it is with the bus stop, which kind of is a cheap way, but it is a way that works. So we say how many 4s go into 6, and it is 1, remainder 2. How many 4s go into 29, and it is 8, remainder 1. How many 4s go into 13, and it is 3, remainder 1. How many 4s go into 14? It is 3, remainder 2 quarters, and we can do that over 4. So 1008. Have I gone wrong? That's not an 8, is it? It's a 7. See, we all make mistakes. We all make mistakes. 1733 and a half. It's a horrible question. In a real science test, they wouldn't give you that question. Okay, next one. Question 12. 2 and 2 times 3 add 4, but the brackets are in there. Now, as soon as I see a problem that looks like this, where we've got timeses, we've got brackets in there, we've got adds, there's a little word that I need to use to help me. And it is, hopefully you're saying it in your heads, BODMAS. So we go through the order. So B stands for bracket. So anything in brackets we're going to do first. So 3 add 4 is 7. Then we do any orders, which are like the kind of like the squares that we had here. So that would be an order. We've not got any of those. We do division, I've not got any of those. Now we do the multiplication. So I'm left with 2 times 7. So my answer is 14. Now if you'd have done that in the wrong order and done 2 times 3, which is 6, add 4, you'd have got 10, which is the wrong answer. Okay, so you must make sure you do it in the right order. Next question. Question 13, 45 times 76. So for this, to me, we've got to be using contracted written methods. So let's go through contracted written methods. So I'm going to do 6 times 5, which is going to be 30. So I'm going to carry my 3 down there in my tens column, and I get 30. Then I'm doing 6 times 4 tens, which is 24 tens, plus those 3 tens. So that's 27 tens. Now at this point, I don't need this anymore. So I'm going to rub it out just so it doesn't confuse us. Then I'm now going to multiply by this 7, but it's not a 7. It is 7 tens. So because of that, I need to move everything up a column. Because if I put it there, I would be saying I've been multiplying by 7 ones and it's not 7 tens. So 7 times that 5 is going to be 35, and I carry that 3 into the hundreds column. Then 7 times 4 is going to be 28 hundreds plus those 3 hundreds, so 31 hundreds. Which leaves me with 12, because that was for that one. 12 tens, carry my 1. 3 hundreds plus that one, 4 hundreds, and then 3 thousands. I'm quickly going to check that I've got that right, because that would be embarrassing if I'm doing it wrong. 45 times 76 equals 3,420. I'm right. I should be a teacher. I should be a teacher. Okay, question 14. Now we are dividing by a 2-digit number, which means that we need a key facts box. Now normally my advice would be to skip this and come back to it later, but we'll tackle it now whilst we're doing it. So I'm going to do my key facts over here. So 2 lots of 14 is going to be 28. 4 lots of 14 is going to be double that. So double 20 is 40, double that is 16, so that's 56. 10 lots of 14 is going to be 140, which means that 5 lots of 14 is going to be half of that, which is 70. Now normally that is enough. Normally that's enough to keep us going for a little bit. So I'm now going to do 3,542. This is the most complicated question on the paper, by the way. And I'm going to be taking away lots of 14 until I get there. Now we've got to do 3,542, which is quite a big amount. If I look at this 28, obviously 28 is not enough to take away, but 10 lots of that would be 280. 100 lots of that would be 2,800. Now that's something that would be good to take away. So I'm going to take away 2,800. Now if I know that 2 lots is 28, I know that then 200 lots is that. So I do that subtraction. So I've still got 2 1s, still got 4 10s. That I can't do, so I'm going to take one of those thousands and put it on there. So I'm left with 700s left. Then I'm now going to look at what else I can take away. Well, I can take up 5 will give me 70, so 50 will be 700. So let's choose a different colour. Let's go for green. I'm going to take away 700, which would be 50 lots. So I've got 2 1s left and 4 10s left. Then I've got 42. Nothing there's 42, so I'll take away the 28, which is 2 lots. Let's do a different colour again. Take away 28, which is 2 lots. And that leaves me with, can't do that, so I need to exchange. So I end up with 12, take away 8, which is 4. 3 10s, take away 2 10s, which is 1. So I've got 1 more lot to take away. I'm running out of space down here, and that would get me to 0. So then I count up how many lots have I take away, and it's 258. That is the most complicated question on the paper. I'm just going to check on my calculator that I've done that right, because again, don't want to look silly. And I have not. Ah, I've done everything and then messed up with this bit. How embarrassing. How embarrassing. Good mathematicians make mistakes, because it's 250 and 2 and 1 is not 8, it's 3. So it's 253. Classic case of done the hard bits and then added up wrong. Year 6, I'm going to say that that was an intentional mistake. So check that you were paying attention. Okay, next question. 1 3/4 add 7/8. So I want to make sure that my denominators are the same and I don't want mixed numbers. So I'm going to say how many quarters are in a whole? Well, it's 4 plus those 3. So I've got 7/4 add 7/8. I still can't do that because I've got denominators which are different. So I'm going to make them both over 8. So 7/8. I've multiplied that by 2, so I need to multiply that by 2, so I'm left with 14. Now I've got denominators the same, so I can do 14/8 add 7/8. And my answer is 21/8. And then rub out, because I need a bit more space. Then I've got 3/5 divided by 2. So 3/5 divided by 2. Now I don't want whole numbers, I'm going to make that a mixed number. So I'm going to say, an improper fraction size, so I'm going to say 3/5 over 2 over 1. Now I know in school we talked about why dodgy KFC works, KCF. I'm not going to get into that today, but we keep the first column the same, so 3/5. We flip this, we change this operation to a multiplier and we flip this round. So we are left with 3 times 1 is 3, 5 times 2 is 10, my answer is 3/10. Okay, last 2 questions. Oh, last 1 question, just 1 to go, and they finish off nice and easy. So 7.62 times by 100. So it means that I'm upscaling, which means that I'm making them bigger. So it's going to go in this place and it's going to go 2 spots. So I'll put my decimal point in and then I'm moving everything up twice. So 1, 2, right underneath. 1, 2, right underneath. 1, 2, right underneath. So my answer is 762. Now year 6, there's a good chance I've made some mistakes in there. So if I have, please let me know about them. And yeah, what I want you to do is just to write, like in the comments, you can take just do a little text on the portfolio space and just tell me what score you got and what you could do next time to improve. So if I was doing it, I would say I scored, I got 17 out of 18. I think it's out of 20 because a couple worked too. I got 19 out of 20 and I went wrong because I made a really silly mistake on the division 1. And that will be enough. Okay, year 6, looking forward to seeing how you've got on with this today. Okay, and I will see you in the next amazing, astonishing, amazing, astonishing I need another A. Someone help me out. Amazing, astonishing, anticipatory, made that word up, arithmetic lesson. Okay, see you later, 6. Bye.